Let's draw the schematic of an inverter using electric. First thing I'm going to do is I'm going to start electric. Then I'm going to adjust the windows. So let me make this small. And now notice I've taken my screen and I've used low resolution so the video displays a little better. I'm going to go to Window, Adjust Position, Tile Horizontally, or I can press T. T is the bind key that I've set this up for. Now I don't have a library open, so there's no cell. If I go over here and I look at the Explorer, I have libraries. No name is my library, which means I don't have a library open. I'm going to go look at my project settings prior to creating a library. And let's go to Scale, and I see that I've got my scale at 300 nanometers. This is the lambda, so I'm using the Moses CMOS design rules. And so the minimum length is 2 lambda, or in this case 0.6 microns or 600 nanometers. I can go set the technology, all this. I'm not going to worry about this in these tutorials. I'm going to set it up for you, and then I'll save the library so you can load it in and play around with it if you would like. Okay, so I'm going to use the C5 process, which is 3 layers of metal. It does have a second layer of polysilicon. And then I'm going to use the scale factor, a lambda of 300 nanometers. So I hit OK. Now I'm going to go here, New Library, and I'm going to call this CMOS. Let's go edu_1, just as an example. Now I'm going to go create a cell, and in these initial tutorials I'm going to use the I'm going to keep things simple. Whoops, I got to type the cell name, so I'm just going to call this inverter _20_10, and it's a schematic, not a layout, so I say OK. Now if I go click on this library here, or open this library, I see there's the schematic of the inverter. Can go turn on the grid, so let's view the toggle grid, or Control G, and again once we get good I'm going to start using the bind keys here and just press Control G to toggle the grid. I can zoom in if I want around the origin. Notice down here it tells what the distance is, so I move around and you can see these are a scale of 1 here. Can go back to the pointer. Alright, so let's make an inverter. So if I go over here, I click on this NMOS device, and there's my NMOS. If I want to change this to a 4-terminal device, I can go up here to Cell, or Edit, Change, or press C, and go up and click on 4-terminal, Apply. There, I'm done. I'm going to leave it where the body is connected to ground of the NMOS and the body of the PMOS is connected to VDD, so I'm going to press Control Z for an undo. Next I'm going to put my PMOS down. Then I'll put ground and power. Now this is the power connector, so if you look in the lower, if you look down here, if I run my cursor over the different nodes, I can see what they are. There's an OR gate, there's ground, there's miscellaneous, there's a wire contact, cell, spice code, wire pin, etc. So, and if I click on here, it tells me I've selected a node called transistor NMOS. Now in electric, devices are called nodes, and the wires that connect the nodes together are called arcs. So here I've got 4 nodes, and you'll notice when I run my cursor over and I get near one of the ports on the node, it becomes a little crosshair. So if I want to connect a wire to this port, I left click, and now here's something you got to get used to. Then I go close to the port and I right click and drag, and I connect the port like that. So here I'm going to move this one over a little. Then I'm going to right click and pull down. So selecting with the left mouse button and then connecting the arcs between the node ports with the right mouse button is how we do this. So we'll left click, right drag, Then I'm going to left click. I'm going to go over here. I'm going to come down. I'm going to go over. And now I have a basic inverter. Now I haven't set the device sizes or the spice models or anything like that. Let's go ahead and set the device sizes. We made this a 20 by 10 inverter, so that means in the Moses Scalable Design Rules, the width of the PMOS is 20 and its length is 2, and the width of the NMOS is 10 and its length is 2. So if I go down here and I double click on this, or I type Control I, or if I want to go to cell info, whoops, where is it? Edit, Properties, Object Properties, Control I. I can go over here and set the width of the NMOS to 10. Now a mistake is if I close it because it doesn't change. What I need to do, pressing Control I, is type 10 and then either apply or just hit OK. Now I've got the screen on low resolution, and so the dialog boxes here take up a large amount of space, but if you have a modern resolution, you'll see that the dialog box doesn't take up much space, and you can leave this open. So I can go over here and I can change my PMOS to 20 and I can apply. Alright, so I've got a 20 by 2 and a 10 by 2, but I haven't set the spice model. So now for these sims, what I'm doing, let's do a save as right now, save library. And I'm putting it in a directory that I've made already called C:electric. And I'm going to post this with the video at cmosedu_1, save. Now I've just saved the cell, so if I go take a look in using Explorer in that directory, I see there is my cmosedu_1 library. Now if I look at these spice models here, c5 models.txt, what I see is my NMOS is called NMOS and my PMOS is called PMOS. And so if I come over here, I select that, and then I go up to Tool and then Spice, Set Spice Model. So it says Spice Model. Now I select that text, do a Control I or Edit, Properties, Object Properties, and then I'm going to make my spice model NMOS, and and I hit OK on there. I'm going to hit Control I again, or I'll do this one more time with Properties, Object Properties, Control I. I'm going to reduce the text size so that it looks a little nicer. Then I'm going to come in and zoom in on that little area there. Use the Control button so I can select that text and then move it down. So if I select here, I can shift or cycle through what's selected using the Control, pressing Control, and then using the left mouse button. So I go up here. Let's do a Tool, Set Spice Model. And then again, I'm going to do a Control I this time instead of going through the Edit, Properties, all that. Call this PMOS. Set the text size to 0.5. OK. Move it down. Now once you've got these models or these device sizes and set up, what you might want to do is copy so you don't have to reset the models and sizes each time. Alright, let's do one more thing before we quit. Let's label some nodes, because when I'm probing, it's nice if the nodes don't have a name. So if I go over here and I click on there and then click on that arc, I hope I didn't say label nodes, but click on the arc and say Control I, this node or this wire, this arc, is called net at 1. Let's call it out. And let's do the same thing here, except I'll just double click on it and call it in. Alright, so let's run a spice sim on this. Now we have this node here is net 0. This node here is net 2, but they're tied to VDD and to ground. So before I can do a simulation, I'm going to take and put some spice code. So I clicked on miscellaneous, go to spice code, drop it in there, press Control I, go to multi-line, and then I'm going to put VDD from VDD to 0, DC 0. That's my power, oops, DC 5 rather, that won't be too interesting. Then I'll put my ground has got a node name of ground, where VDD has a node name of VDD. I'll put VGND from GND to ground DC 0, so it's effectively connecting the source of the MOSFET to ground through DC supply. Then I'm going to do a dot include, and then I put my models in this directory, electric, in there C5 underscore models dot text, so it knows where to find the spice models. Then I'm going to do a DC sim, and I'm going to sweep VIN from 0 to 5 volts in 1 millivolt increments. Now I'm going to say, okay, now I've made a mistake. Oh, let's go change the text size. Whoops. So we click over here, type Control I, and then I'm going to change the text size so it looks a little more reasonable to 0.5. Go over here. Now I have VIN from 0 to 5 volts with 1 millivolt steps, but I have no VIN in this circuit or in this schematic. So I can go put a voltage source in there. I could put a DC voltage source. Why don't I do that just to put it in? Connect it up to ground. Again, right click and drag, left click, right click and drag. This node is called VIN. I'm going to select that input voltage, call it VIN, and now I'm going to make a mistake here. So this is VIN, and I'll leave it like that. Now I'm going to generate a spice netlist. Let's, whoops, how do I get that VIN? Oh yeah, I press Control. So let's drag that over here. Now the mistake I made is when electric generates a spice netlist, it puts a V in front of all the voltage sources. So let's go generate a spice netlist and then look at the netlist before we simulate. So Tool, Spice, Write Spice Deck, and I set my bind keys up so I could just press S to write a spice deck. So I write this, and it's called Inverter 2010 SPI, so I say save, go back to that directory. I'm going to open with Notepad. Whoops, let's not use Notepad. Let's open with WordPad. And I come down here, and even though I specified an L of 2 and a width of 20 or 10 for my NMOS, I get the scale factor in there that sizes the devices correctly. Notice my NMOS goes from the drain is connected to the output, the gate is the input, the source and bulk are connected to ground. Now here's my mistake. I have a VVN connected from in to ground DC 0. So I need to go back and change the name just to in, because electric will automatically tack on a V because it's a voltage source to the input. Okay, so I'm about ready to go. So close this, go back here, do a Control I, and just change it to in, apply, make sure I don't click there because it won't make the change. And now I'm good to go. So let's see what happens if I generate a spice netlist this time. Write spice deck. It's going to say, do you want to overwrite that? I'm going to say yes. So I'm going to go back now and open it up. Now I have this netlist associated with LT Spice, but you could use H Spice or whatever you wanted. In fact, let's make it so that you can use that H Spice by going here and typing Control I and then put a dot options post, and I'll simulate it both ways. Okay, so now let's regenerate the netlist again. Yes, I want to overwrite that. So go back in here. Now if I double click on this, LT Spice will run up, and I'll type V in and V out just to see what happens. And so you see there's my output going down, there's my input going up, my inverter action, and I can adjust the sizes if I want or do whatever I want at this point. It's important that you understand the makeup of the netlist and you can write this simple SPICE code here. So let's go simulate this with HSpice just to show we can. So let's get HSpice going and then open, and then my computer, local disk, electric. Now HSpice likes files with the .sp, so we have a .spi here. Why did it put an SP? Let's go to Edit Netlist and see. Okay, it cannot find that file. So what we're going to do, it's good to do this and have problems. Let's go over here and rename, and then I'm going to put quotes. Whoops, quote. Okay, so I've changed it so the extension's .sp. Then I'm going to go Edit Netlist just to make sure it's there. It is. I'm going to simulate. And let's see. OK to terminate. I don't know what just happened there, but let's see. Let's troubleshoot it. Okay, we've got .dc vin 0 to 5, .options post, .include, vground. Let's go open the netlist one more time. Edit netlist. Okay, let's try simulating. Alright, I don't know what was wrong, but it worked fine that time. And then let's pull up cscope. Cosmos scope. And let's maximize that. Whoops. Yep. Open. There's our output file. And we have VIN and VOUT. Let's plot those. Oops. There's VOUT. There's VIN. We can move this over and drag it on, etc. Alright, so let's stop right here. Before I do that, let's exit the various software. And then let's go up and save this. And then when we come back in our next one, I'll start by modifying this. Just so we can see in the Explorer, I've only got one cell and it's an inverter schematic. Alright, so let's close this and stop.